Okay, so time is already 6 o'clock. So shall we start?
Yes, Dr. Rajan, you may start. Participants will join. They are
Okay,
coming.
okay,
I
okay.
made
Thank you, sir.
reminder. You can join. You can
Yeah,
start,
thank you, sir.
please.
Thank you, sir. So good evening to one and all. So welcome to fourth day of FDP on thermal poly generation for sustainable energy development, organized by the Department of Mechanical Engineering, Dr. B.R. Ambedkar National Institute of Technology, Jalandhar, Punjab, India. So it is my privilege to welcome and introduce our esteemed expert for today's first session, Engineer Kushagar Juneja will be delivering a lecture on energy modeling and building performance simulation for poly generation. Engineer Kushagar Juneja is a founder and partner of a partner at Design to Occupancy Services LLP at a sustainability and engineering consultancy firm operating internationally. The firm in his leadership qualified as a finalist in National Startup Awards in energy efficiency category by the Government of India. He has various international and government certifications, including being a BEE certified ECBC master trainer, lead AP, besides others. Mr. Juneja was also awarded the Rajasthan Energy Conservation Award for the year 2016 for his contribution towards energy efficiency in the state. He has been invited as a speaker on several forums. He also serves as a vice president of Indian Building Performance Simulation Association India and as advisor to GEM, National Council of ASSOCHAM. His area of expertise includes sustainability in built environment, energy efficiency, green buildings, and mechanical design services. His core interest lies in sustainability, energy efficiency policy, and education related to it. He has worked with multiple state governments for implementation of state level energy efficiency program in buildings. Industries carries a vast experience of working internationally. He has worked on several assignments in USA, Nigeria, Bangladesh, Saudi Arabia, Maldives, UAE, Argentina, and many other countries. So we welcome, sir, we welcome you to this session.
Thank you so much, sir. Thank you for the kind introduction and really appreciate you, Dr. Srinivas, for inviting me to this August gathering. And I hope I am able to add some value by the time we end this session. And look forward to a lot of interaction from all the participants. I'm sure all of you are stalwarts in your own areas and already have a lot of expertise. So what I'll try to do is uh, talk about some practical aspects in thermal poly generation uh, that we come across in the industry. Thank you once again for inviting me, and I'll just share the presentation if somebody can confirm if it is visible. Is the presentation visible?
Yes, it's coming.
Great. Great. Uh, so thank you everyone for joining. Sustainability and energy efficiency is a very close to heart subject, and I've been in the industry for a good long time now. Honestly speaking, the subject is extremely vast, has no dimensions. It's almost like medicine, which has so many dimensions that how much ever expertise you have, there is always a lot to learn. And I have been fortunate to have been even taught by Dr. Srinivas in my early years. So I hope I'm able to do some justice to this August gathering today. Uh, So let us talk about the whole discussion around sustainability, and eventually, as we progress through the session, we will also come to the thermal poly generation aspect of it. But what is the whole discussion around energy intensity, energy efficiency, and what is the real need that we say now? Every country is rushing to become energy self-dependent. We are trying to reduce focus on fossil fuels. The Prime Minister in COP26 promised Panchamrit, and Panchamrit was focused around energy efficiency, which says that we'll reduce dependence on fossil fuels. Our carbon intensity will reduce by 45% by 2030 as compared to 2005 levels. We will also add 500 gigawatt of renewable energy capacity by 2030. We will be net zero by 2070. So five moon mantras or five uh, basic principles were adopted by the Prime Minister in COP, and the whole policy framework around sustainability in the country has been circling around that Panchamrit goals. So it's a very good thing that we have leadership at the top who is uh, committed to achieving a sustainable and energy efficient future, and also reduce our dependency on oils and fossil fuels. Where do we stand currently? We were about 202 gigawatt out of 500 gigawatt by 2023, if I'm not wrong. I don't have the latest figures as of this year. But 2023 it was 202 gigawatt. Just to put things into perspective, China added 300 plus gigawatts in just last year. But there can be two ways to look at it. One, that we are very behind. China is adding 300 in 1 year, and we are trying to add 300 in 7 years. So where do we really place ourselves? But the honest matter of the fact is that the infrastructure that we have also needs to be upgraded. There is a lot of uptake that needs to be upgraded. There is a lot of substation level infrastructure that needs to be upgraded. That eventually will catch pace, and maybe the initial addition of renewable energy may take some more time, but eventually we'll reach a point where we are able to add hundreds of gigawatts in a few years' time. So that is the overall aspiration that we are looking at, but only renewable energy cannot handle everything because we are a growing economy and GDP is continuing to grow. And as GDP grows, we all have seen the energy consumption always has to go up. So if you talk about in the future slides and the further slides, we'll also see how other countries consume. But as the GDP grows, energy consumption is bound to grow, and the quality of life assessment also one aspect is how much per capita energy consumption is. So, according to the Niti Aayog and other international sources, our energy intensity. Now, what is energy intensity? Energy intensity is how much energy we consume per INR of GDP that we generate. So, if I do 1 rupee of business, how much energy intensity do how much energy do I consume? So, it is at about zero point 0.2 megajoules per INR of GDP. And a realistic estimate of energy intensity of energy efficiency or energy consumption or energy demand is energy intensity and not the demand itself, because you cannot stop the demand from growing, but what you can reduce is the intensity. So for example, a normal fan was taking 70 to 80 watts of energy up till, let us say, 3 years ago. And all of us, we live in a composite climate zone where we have excessive summer during the summer time. And these fan wattages now, BLDC fan technology is being used. And the fan wattages have drastically come down to 30 watts and even 28 watts. And a lot of new companies are coming up and offering these fans. So, though earlier my house might have had only one fan, and now I have progressed economically, and now my entire house has fans, and all four rooms have a fan. But earlier my one fan was consuming 80, but four fans is not consuming 320, it is consuming only say 120 watts. So though requirement has gone up 4 times, but my consumption has gone up only 1.5 times. So that is how we have reduced energy intensity. Fan is a very relatable example, so I always use this example. But even in other sectors, if we talk about cement sector, if we talk about textile sectors, Indian industry is ranked as one of the most efficient uh, industries in the entire world, where our specific energy consumption, which is energy consumed per kg or per unit of the product produced, that specific energy consumption has gone down by a lot, and that overall contributes to a lot of reduction in energy intensity. So, what has really impacted economic structural shift uh, has definitely impacted. We earlier used to focus, and there's still a lot of focus on manufacturing, but there is a lot of also focus on servicing. We've become a hub for healthcare. We've become a hub for IT. A lot of healthcare tourism happens in India. We have become a hub for hospitality. There are a lot of great hotels that find their abode in India, and services-based economy has really led to GDP growth. So when a country is driven by services, the energy consumption will definitely be lesser than when it is driven by manufacturing. A lot of energy efficient technologies in industries and households have come, and that is not limited to the BLDC fans I spoke about, but also a lot of other technologies. Like earlier, the star rating of air conditioners was 5 star at say 3.28 COP, and now it is about 3.5, 3.6 COP. Chillers used to be available at 6.1, 6.2, now they are available at 6.8 COP. A lot of new technologies also keep coming every now and then, and we keep seeing the per unit energy consumption or the per process served energy consumption is going down. Renewable energy has grown, solar, wind, small hydro, a lot of battery tech is now coming up. And in fact, we talk about fintech, we talk about ed tech, and you might have heard these terms from the startup community and from the students that you work with. But now there is also climate tech and there is also sus tech. So eventually sus tech, and we are the good part about India, the good part about the country, we are very good adopters of technology. So whenever new things come up, we are very fast to adopt. A few years back, you will see that Zomato and Swiggy were not there, and there were no means to order food from restaurant with such ease as we do today. But only within a few years, we are now heavily dependent on Zomato and Swiggy, and this is just an example of how quickly we adapt to technology. So this adaptation has also happened in a lot of other industries, including the energy intensive industry. And I always give this example: sustainability is one area where the government ministries work so much that we have so many ministries, so many departments that are doing something or the other in the sustainability sector. For example, if I talk about, we have Ministry of New and Renewable Energy doing something, we have Ministry of Power doing something, Ministry of Housing and Urban is doing something around affordable and green housing. We have AICTE that is working on green audits for campuses. We have CBSE that has launched the Shunya curriculum for school students that promotes net zero. Ministry of Finance has mandated ESG reporting for SEBI, top 1000 SEBI registered companies. And every ministry, railways is doing some amazing work in sustainability. So overall, if I talk about sustainability is one key area where even ministries that don't directly work in sustainability find their some route, some focus, some direction in and around sustainability. And I think it's a very good sign for the nation that we are also looking at conserving resources, we are also looking at efficiency, we are also looking at growing, but growing with a pace that we can sustain. Because haphazard growth can be fast, it can be quick, it can I'm sorry, can yield fast results, but it is not sustainable. And I think the world is about sustainability. If we have to feed a couple of billion population, I think sustainability is the only route forward. Electrification has increased, better energy management is coming up. We have prepaid metering that is happening. We have uh, a lot of smart grids that are coming up, grids that are able to manage their loads through AI. the whole DISCOM space, the whole electricity distribution and supply network has been privatized in some areas, some states, which has also led to a healthy competition where now these DISCOMs are trying to focus on efficiency of distribution and not just distributing. Also, collection efficiencies, billing efficiencies, all these terms are now relevant because these have increased in the past so many years. And uh, eventually, we are progressing to a level where electrification is not just leading to higher consumption, but it is also leading to better management, more efficient management, and more efficient use of the utility services. Since you all are in Punjab and NIT Jalandhar is based out of Punjab, we'll talk about the global and the Indian context as well. But let us talk about a little about Punjab so that we'll contextually get related to what we are talking about before we delve deep into the subject. So we have a population, and this data is from 2020 because this is the last data that was available commonly across all sectors. So about a population of 2.5 to 3 crores. A GSDP. What is a GSDP? GSDP is the state domestic product, whatever value we add to the state domestic product. So it is about 5.3 lakh crore. Uh, Total power plant installed capacity. Punjab is a very rich state. It is about 9.6 gigawatts with a renewable energy capacity of about 2.6 gigawatt, which is quite a lot, which is almost 25% of the total installed capacity is renewable, which is a very pride thing to do, and that happens because of a lot of hydro ecosystem and a lot of canal solar that has happened recently on the land of Punjab. Electricity consumption is 47.15 terawatt hours with coal consumption limited to 0.42. There is a differentiation between primary and secondary energy consumption. Primary energy consumption being generated directly by primary fuels such as coal, and electricity and other sources become the secondary energy consumption. So coal consumption captive is about 0.42 MTOE million tons. Non-power coal consumption is about 0.65 million tons. Imported coal is about 7.36. So the whole narrative around becoming energy efficiency, self-sufficiency, and reducing a load on imports, you can see that our imported coal outrightly beats the domestic coal by a margin of over 10 times. We are importing about 7.36 tons of coal annually in Punjab, and this is a lot of coal, and importing coals also means foreign exchange going out and currency weakening. So eventually, if we are not how much ever exports we do, how much ever products we export, if energy is being imported, it is going to dominate, and we will always be an import deficit, export deficit nation. Oil consumption, again, a lot of it is import, which is 7.34 million tons, and gas consumption is 6.54 million tons. So these are the total final energy consumption of the state is about 14.95 million tons. So if you look at the numbers, they're quite huge for a state of Punjab. How does energy flow happen? Renewables are there, coal power utilities, coal is there, coal captive power is there for larger power plants like cement. ACC has a big plant in Punjab. A lot of other cement companies are there. So a lot of captive power comes from coal. Non-power such as that coal that goes in steel production, other industries, fertilizers, that is non-power coal. Then we have oil, we have gas. And what are these supplying to? This is the supply at the top, and then consumption happens in electricity generation, coal power, which is captive, coal consumption directly in the industry, oil consumption directly in the industry, domestic, commercial, transport, agriculture, and other sectors, and gas consumption in industry, domestic, commercial, and transportation. So this is the whole gamut of picture what fuel is being used. And when we talk about generation, we should understand where is the energy coming from, where is the energy flowing from. And these slides are the part of the State Energy Efficiency Action Plan that we were developing for the state of Punjab along with Ministry of Power. And all these things were very thoroughly analyzed, that where is the supply coming from, where is the consumption happening, and thereby strategies were formulated that, this is the pain point, this is why we are still not energy sufficient, and this is what our strategy should be in the long and the short term to tackle energy efficiency in the state of Punjab. Energy consumption scenario is such that we have covered on the graph in the left. Oil, coal, electric utilities, coal imported, coal captive, and gas. So you'll still see that oil forms about 670 OE. Non-power coal is very little. Electric utility coal is very high. Coal imported is pretty high, and coal captive is also a very marginal percentage, followed by gas. So, but all of these things you will see if I look from 2015 to 2020, it has fairly remained stable, and all this can be attributed to better efficiency and lower growth even in GDP. We'll talk about GDP growth in the slide to come. Also, sometimes if GDP growth is led by agriculture, is led by service sector, is led by transportation or similar areas, then the energy consumption does not grow at the same pace as it is growing in other states where which are maybe more industrialized, and the focus of consumption is around manufacturing, is around actual fuel burning and fuel consuming areas. Total final energy consumption is a breakup of oil, coal, electric utility, imported coal, captive coal, and gas. If you look at it, oil forms about 22%, whereas oil forms about 47%, whereas coal forms about 22% of the total consumption. Whereas electricity, which is again a byproduct largely of coal, because renewable energy is still a smaller percentage, forms about 27%. So the picture you will see here is that we still have a lot of dependence on fossil fuels, and though we are having very high aims, there is a PM Kusum scheme that is trying to solarize agricultural pump sets. There is a grid feeder separation that they are trying to do, which will separate the agriculture feeder than the industrial and domestic feeder to better manage agriculture utilities. And other schemes where farmers are being trained, industries are being trained, municipalities are being trained, pump technicians are being trained. At all levels, efforts are being made to make sure the consumption does not rise as fast as the GDP, and we are able to be sustainable. Uh, so the source of the entire data is coal, Directory of India, and oil is the MOPNG report, and electricity is the CEA website. What is the projected scenario? If I talk about the state economic scenario, like I said, it is very imperative that if the GSDP or GDP will grow for the state, there will definitely be growth in energy consumption. So a model was run to predict what will be the level of energy consumption, and we will almost double our consumption by 2031. Um, so we'll double our consumption by 2031. Uh, and that is why, since we will double the consumption by 2031, efficiency, things like poly generation, fuel cells, newer technologies, all these are enablers to curtail this consumption. GSDP growth, we cannot say let us stop growing. We are a growing economy. There is a lot of opportunity for youth and the upcoming generations to actually create value, uh, increase value in the value chain, the entire value chain. And Punjab has always been a very prosperous state in terms of agriculture, in terms of resources. And I'm sure that this GDP growth can definitely be curtailed if proper strategies are implemented at proper times of the year. So the bottom axis shows the years. The blue and green bars are the GSDP. The blue ones are the current GDP, GSDP, and remaining are projected GDPs. Energy consumption is also poised to grow to about 12.56 MTOE, and you will see that the steady growth of GDP will definitely lead to a steady growth in energy consumption. And though energy generation is also going, but the government of India is actively trying to not grow it through more coal plants, through more non-sustainable means, and the push is totally towards renewable energy sector. I hope there are no questions so far. If there are any questions, feel free to write it in the chat box, and we can take it towards last 15 minutes. We can keep towards uh, answering questions. So, uh, so yeah. So we spoke about what context we are talking about where we stand as a country, as a state, what is our potential, what is the fuel distribution. So we have the problem at hand. We know the problem at hand and we know what we are facing. If I talk about comparison with other countries, there are both ways to look at it. One way to look at it is energy intensity, which is 4 to 6 megajoule per USD. India, China is 5 to 8 megajoule per USD. US is 2 to 3 megajoule per USD. And we will get because US you will appreciate is a very research based economy, and though they are more efficient, the cost of production, the cost of things is very high, and the cost of things is high because they spend a lot on research. So research will go up, so efficiency will come down, but we are declining at a good rate, and I'm sure that within the next few years we'll be able to compete with the US. There are a lot of good programs started by the government of India. One of them is Perform Achieve Trade program, which is PAT. And all big, large industrial consumers or large commercial building consumers come under PAT. 10 cycles of PAT, I think 11 cycles of PAT have already been notified, where industries are tasked that they have to reduce their energy consumption by 3% every 3 years, and they are mandatorily required to report the decline in energy consumption through a PATNet portal, and the government can officially, it is notified in the Electricity Act, and the government also sends notices to non-compliant people. Though it can look like a very inspectorish or a very policy driven thing to push energy efficiency, but I think it's a amalgam of strong policy push along with need at the industry level, because when an industry gains efficiency, when an industry looks at compliance and it looks at the saving that it is able to achieve through that compliance, the industry also appreciates because it makes it cost competitive. So energy efficiency, technologies around power generation, all these are not cost centers, they are uh, saving centers, they are profit centers, because they drive savings, they drive the product cost lower over the years because of declining energy use that they use over the years. So, how is energy requirement determined? The total energy requirement is determined by economic growth, industrialization, and the population needs. If I talk about the energy consumption, we were about 960 MTOE in primary energy consumption. Electricity demand is about 1750 terawatt hours, and per capita is about 25 to 30 gigajoules. Now, uh, one way to look at it is that we are not developed and we are not growing, and that is why the energy consumption is low. The rural households don't have energy consumption because they are spending on fans and coolers, and they don't have air conditioning load. But the other way to look at it is also that we are mindfully trying to keep the consumption low. India already has an India Cooling Action Plan in place which tries to reduce the intensity of cooling. Cooling is one area again where a lot of energy is spent, and that energy will only continue to rise because the access to cooling has increased. As we grew up, and even when I was studying, and a lot of you, I'm sure, were studying, there were no air conditioners in the classroom, and summers were tolerable. We as humans were more adaptable. But as we are getting more access to cooling, the energy consumption is also going up. And India is lucky to have GHG gas or CFC reduction program, uh, India Cooling Action Plan. We are a country which already has a very strong star labeling program that happens in already a lot of devices, a lot of equipment is star labeled, like your air conditioners. I think 14 equipment are mandatorily star labeled, and about 20 equipment are star labeled on a voluntary basis. But even that, if I talk about, star labeling has played a very vast role in educating the end consumer about energy efficiency, and it is one program that has really driven energy efficiency at the household level. So per capita energy consumption might be really low as compared to the global average, but it uh, not entirely showcases lack of development. It also showcases our commitment to reduce energy intensity, to keep it in a check, and to ensure that we only consume what we can sustain. So about 45 to 50% is coal, about 25 to 30% is oil, about 6 to 8% is natural gas. Uh, and the percentages are different because these are ranges where they vary from one state to the other. States like Kerala have low industrial consumption. States like Chhattisgarh have very high coal consumption because they generate a lot of energy. States like Rajasthan, Karnataka have nuclear power plants, so they have a lot of nuclear role. So this is a overall mix that varies from one state to the other, but this is not a benchmark that the entire country follows. For example, we already saw the mix that we have in Punjab. Solar and wind are fastest growing energy sources, and even more than wind, now solar is picking up even at the policy level uh, at a very, very fast pace. So the energy consumption, the energy demand is expected to reach 50 to 55 exajoules, which is 1200 to 1300 MTOE by 2030. We're driven by industrialization, urbanization, and electrification. Renewable energy is expected to increase to 30% by 2030, which is a great news because if we are able to generate that much renewable energy, then the reliance on fossil fuels will definitely go down. We have a lot of national missions uh, that talk about, I think if I'm not wrong, there are about 12 national missions. There is one called NMEEE, which is National Mission for Energy Efficient Economy, that talks about energy efficiency. Then there's a National Bioenergy Program, National Solar Mission. So a lot of national missions are also going on that make sure and that give the policy push to the industries to make sure they become competitive. They get funds for piloting different projects, and a lot of capital is being floated to make sure that eventually the returns are achieved in terms of energy efficiency and we have more energy resilient as a country. So central financial assistance was also being offered. A lot of pilot programs keep happening, a lot of pilot projects keep happening funded by the state and the central governments. You'll also be surprised, and I'm sure a lot of you might already know, but a lot of states also incentivize for doing energy audits. You get capital reimbursement in India by a lot of states which pay you up to 75,000 rupees, somewhere up to a lakh of rupees for conducting energy audits, especially in the MSME sector. There are a lot of MSME development programs that keep happening that enable MSMEs to be more sustainable. A lot of training programs to enable MSMEs to appreciate what is energy efficiency and to make sure that they understand that efficiency plays a larger role is very strongly being pushed. Other than this, CBAM has now come, which is cross-border adjustment mechanism, which a lot of products that are being exported are now notified under CBAM, and a lot of customers are now also asking users to report their energy efficiency, users to report what is their per product specific energy consumption, etc., etc. And therefore, there is a all sides push right from the level of the customer, from the level of the government, from an award and recognition point of view. A lot of things are being done parallelly, and it is being ensured that energy efficiency is achieved with no stones unturned. Cogeneration technology and innovation, high efficiency gas engines, advanced engines with optimized. So we are now coming to the traditional cogeneration, which is advanced engine with optimized fuel consumption and energy improved efficiency. We have combined heat and power units for residential and commercial use, which also are in the form of uh, things like heat pumps. How many of you have heard of heat pumps? Uh, so heat pumps are very effective solutions, and if you would appreciate low temperature heating of water up to 60 to 70 degrees centigrade, and also element of cooling is combined in a combined way given through heat pumps. Though it is not a very popular system, but now even in hotels and in larger places, larger commercial buildings, heat pumps are now becoming the mainstream solution for cooling as well as hot water generation. Though they are also being used along with other mainstream electric heating and other things, but they definitely serve the base load at a very low cost. I was speaking to a hotel GM the other day, and heating and power, HLP they call it, heat light power, used to contribute 20% of hotels' operational expenditure, because the electricity bill and the energy bills are very high. And as we speak today, as I speak today, a lot of large hotel chains have come down to a heat light power consumption contribution to only 4 to 16%, 4 to 6% of operational expenditure. Since we work with a lot of hotels, and hotels are massively uh, electricity consuming and energy consuming, this is a real achievement that we have as a country. That, and hotels are also touch points for a lot of customers. So it also serves as a good purpose when a hotel starts educating and a hotel starts preaching sustainability and follows it on its own in a larger level. So waste heat recovery is also another smart thing to do. Air conditioning waste heat recovery, already we have outdoor units and economizers are placed, heat wheels are placed in alignment with the outdoor units, and waste heat recovery solutions are derived from there. So waste heat recovery is a very important aspect, and very, you will be surprised to know that it has become very mainstream, and we don't have waste heat recovery solutions only from larger manufacturers, but even in states like Punjab and Himachal Pradesh and Haryana, which are not extremely large lands of industrial activity, even these states have a lot of manufacturers now that are able to manufacture waste heat recovery solutions. So earlier, 5 years earlier, if I talk about, see, whenever you talk about energy efficiency, the other discussion comes about is at what cost. And commercially speaking, if you want to implement anything, the payback has to be within 2 to 3 years. Otherwise, nobody will spend their capex or the capital cost on sustainability measures just for the heck of sustainability. So waste heat recovery solutions, economizers, all these things have been very summarily implemented at a larger level, and the implementation is so deep that even in all IT buildings, economizers, waste heat recovery systems, heat pumps, all these technologies are now being used. There are states that have come up with extra FARs, extra floor area ratio. Punjab also has extra floor area ratio. Rajasthan, the state I am sitting in, also has a floor area ratio extra for green buildings. And green buildings have also played a lot of role in making sure that these systems get implemented, that efficiency gets a notch higher, and that technology gets a push. Uh, a lot of it, hybrid systems can also get integrated with the renewables For example, biogas, hydrogen and synthetic fuel. Uh, there's a fuel blending program nationally going on, which has permitted mixture of ethanol up to 20% in all vehicles, in all fuels. We already are at a level of 5 to 10%. Even at topping cycles of a lot of power plants, briquettes of waste, straw briquettes, etc., are being used as fuels, and integration of it with renewables, with biogas, with hydrogen has really taken place. Government also gives a capital subsidy if you set up a green hydrogen plant. Now, hydrogen is categorized into green, blue, grey, etc. And green hydrogen plants also have a capital subsidy by the government of India if you are installing any green hydrogen plants. Smart grid compatibility. Now, grid stability is single most important aspect to ensure different renewables get integrated into the system, because renewable energy comes with a limitation that it may not have as continuous generation as a coal power plant or a gas-based power plant, and that is why grid-based solution, grid stability is very important, and smart grids are now coming up uh, nationally, where the real-time monitoring happens and automation happens for this optimized energy distribution. So, cogeneration, the new developments lie around next-gen fuel cells, adoption of. So we are a very uh, generation is now moving in the right direction. The next big push, we always say that renewable energy, solar has done really good and it has now reached the masses where every household knows what solar is. They know the benefits, and you don't have to explain to even a residential customer that what solar will do for them. There is such good uptake even at the residential level. Similarly, the next big push is around batteries. 5 kilowatt battery is already costing about 50,000 rupees. A lot of it is imported right now. We are not producing battery cells as of today in India, if I'm not wrong. But eventually, there is a very strong push to promote all the storage technologies, and these storage technologies also will drive way to net zero future. Once you are able to install a lot of renewable energy and you can store it in your own house, then you don't have to rely on the grid. And if a lot of users are able to do that, then eventually we will become more energy self-dependent. So, fuel apart from fuel cells at higher efficiency, which becomes an affordability challenge, uh, it is also important that that battery tech and storage technology also gets elevated and it gets adopted as rapidly as the solar rooftop scheme did. Carbon capture is a very, very interesting subject, and you can imagine what can be made out of carbon capture. A power plant which is working on a topping and a bottoming cycle, which is utilizing heat, can also utilize a soot. What is a soot? Ash we are already utilizing in making fly ash bricks. Now, chimney soot, which is going out of the chimney, is being collected and being compressed, and it is being used to maintain floor tiles. Can you imagine that, floor tiles are being made out of, uh, and this is not a product that I am importing out of US or any developed economy. This is our own Indian product by a tile company. There's a tile company called Carbon Craft, and you can Google them. And we have in fact installed their tiles in our office, and I mean, they are compressing the soot, the chimney soot, integrating it with cement and producing beautiful tiles. Though it is very cost prohibitive right now, it is 300 and 350 rupees per square feet, which is a lot of cost. You get, just to give a comparison, you get reasonably good Italian marble for 350 rupees. So you may not want a tile, but we are in that direction where eventually these technologies will become cheaper. Eventually these technologies will become affordable, and the carbon capture is a very, very interesting technology that is being used. AI-based predictive maintenance, AI is doing a lot of human work, and predictive maintenance is one important aspect. District energy systems. What is district energy systems? We already have a very good example, and if you talk about the West, they have a lot of district energy systems. But in India, we have a very interesting example of Gujarat infrastructure, the gift city, as we call it. The gift city has a full line of district energy system. What is a district energy system? So, like you get an electricity line, you get a water line or a chilled water line, and the chilled water line is piped to your house. And when you run your air conditioner, the air side system is the only system that you have to install, and the cooling is done through a central supply of cooled water, and you are billed, you are charged for that cooled water that you utilize. So you don't have to really spend on generation, and since water has a very uh, high specific heat, water is able to carry that cooling with it and through large distances and through insulated pipes, and district energy systems then become very efficient systems where maintenance of cooling becomes easier, and also balancing of load becomes easier. Also efficiency becomes much better, because we are talking about a large system serving a large society, or a large household or a large industry, rather than every one of us putting individual systems in our houses. And Gift City has beautifully implemented district heating systems in their entire town. Government incentives are there and policies that are supportive. Bureau of Energy Efficiency, Government of India, Ministry of Power does that a lot around the policy support. And CHP adoption, the combined heat and power adoption via subsidies and regulations is also promoted. Tri-generation absorption chillers utilizing waste heat for cooling applications and reducing energy costs. Hybrid energy storage combining electrical and thermal storage for flexible energy use. Smart control systems, AI-based energy management for balancing heating and cooling power. Compact and modular systems, scalable tri-generation units for varied applications. And future-proofing tri-generation for clean fuel adoption. So all these systems, whether it is a control system, it is a storage system, or it is providing cooling in a certain way, is very effective. And believe me or not, but a lot of this is already being used. And as we speak, the technology is only going deeper. Uh, Biogas used to look like a government project earlier, and only government was pushing it. Now there are billion-dollar companies in India which are leading biogas and providing that biogas systems in hotels and large commercial buildings, and it is creating a lot of difference. Polygeneration, which is multi-output systems, as we speak about in this session, is all about technology and innovation. Uh, Localized polygeneration units, reducing transmission losses, the desalination and water purification using waste heat. Can you use AC outdoor waste heat for drying applications? Can polygen systems for hydrogen, biofuels, and synthetic gas uh, give us fuel flexibility? So all these are questions that are being answered, and we have a limitation of time. We only have a small session of 1.5 hours. So I broadly am trying to explain and to cover what all exists in front of us today. And if any deep dive discussion is required, I'm always happy to come communicate on email or even set up Teams call if required. Just to bring your attention, we have also made a net zero building for our own office consumption in Jaipur, in Rajasthan. So if any one of you ever happens to be in the city, we would love to host you. And a lot of these technologies that you see here have been actually, not a lot, but a few of them have definitely been implemented in the building. And not only this building, Punjab is now coming up with its own net zero super ECBC building for Punjab Energy Development Agency's office. And such buildings and practices are now becoming mainstream. We have always heard about waste is wealth, and you cannot even imagine how many things can waste produce. So there's a very classic example of waste being managed so well by Hyderabad municipality, where one waste management company has done so brilliantly that they have created the mountains of waste that you see are now so beautifully landscaped that you will start feeling that it is a real mountain and not a mountain made up of waste. They process waste to generate landfill gas and generate power from that. They process waste to generate refuse derived fuel, RDF. They process waste to generate uh, manure. They process waste to actually make the waste business so financially competitive that they are charging the municipality for waste handling. The municipality has given them free of cost land to process waste, and they are also making revenue through selling manure, through selling energy, through beautification, and eventually the idea is to make sure that the waste mountain does not look like a mountain where all eagles and vultures come and eat the waste, but a very serene place which is not even affecting the local community. And the local community has been so well integrated, because all other places where we see waste handling, we see lot of community opposition because it spoils their neighborhood being next to a mountain of waste. But here in this case, it is very important to note that this is not just another project, and it is an example for everyone. And working with municipalities, because the municipal governments function very differently than the state and the central governments, it is not an easy thing, but you are able to generate power, you are able to sell the fuel, you are able to sell the manure, is a very big feat. And in fact, using the manure in extra spaces, they are even growing veggies which they are now trying to utilize for their own uh, organization and team. Carbon neutral industrial plants are now picking up. Poly generation is in being practiced in green manufacturing facilities. Energy storage using thermal and electrical storage, even flywheels, potential energy used to store energy, electrical storage. Chillers have ice storage systems that, when electricity rates are cheap or renewable energy is available, you can make ice, and eventually at the night time when you don't have renewable energy access, you can use the same ice to actually use cold water uh, uh, to cool the building or cool the facility. Grid interactive poly generation, smart integration with national grids for flexible demand response. And demand response is often been talked about, though it has not been 100% implemented in India. But the West is a very good example of demand response, where time of day controls and grid management has really led to users being conscious users of their energy guzzling products. And it has also constantly evened the demand, because generation is one part of the story, but if your demand is uneven, no matter how efficiently you generate, eventually there will be inefficiencies that will creep in the system. Circular economy integration, waste heat and byproducts used in various industries. Generation, generally speaking, is an advanced energy production technology or process that simultaneously generates multiple useful outputs. And we spoke about electricity, we spoke about cooling, we spoke about fuels, we spoke about chemicals from a single energy source. This system utilizes, minimizes waste, utilization improves, and also enhances sustainability. Now imagine a power plant which is multi-cycle. Soot is being used to make tiles. Uh, Fly ash is being used to make bricks. What is the waste? There is no waste that is going out. So every inch of space that you have for utilizing of resources is being utilized. And with this, we are not only impacting our energy ecosystem, we are also reducing our waste generation and our material consumption. And ultimately, if material consumption will go down, we will definitely ensure that the going down material consumption will add to economic progress in terms of lesser dependability, and we can focus on more important things, and the budgets can go in directions of better use, where it is saved from importing oils and other uh, fuels. So biogas, for example, is can be used for cooking, and then it can also be used for generating also bio slurry, and then you can also generate electricity, and then the waste heat out of electricity is used for fertilizer, and then again a thermally driven refrigeration system can reduce the cooling demand of the milk. So one polygeneration plant is serving so many different purposes that not only it is feeding the plants, it is feeding us electricity for various purposes, it is giving us heat for drying, it is doing cooling for refrigeration and even thermal cooling of spaces. So these are areas where a lot of work is already ongoing, and polygeneration is now picking up as a concept. What is the process of polygeneration? The primary energy input uses diverse fuels like natural gas, biomass, hydrogen, or waste materials. Energy conversion uses fuel, undergoes combustion, gasification, or any other conversion processes to generate power. Heat recovery is captured, repurposed for heating, cooling, and industrial applications. Depending on the system generation design, polygeneration can also produce desal water, hydrogen, synthetic fuels, industrial chemicals. Integrated system efficiency, which includes all these that are listed above, apart from smartly controlling the systems, smartly controlling the distribution, and making polygeneration a very flexible and a sustainable energy solution. So polygeneration is the final answer that we all have. What is the final generational option for a rapidly growing economy that thrives on its energy use, and therefore polygeneration is becoming very handy. So if I talk about the wind turbine, the grid, the PV, all of this can feed in with an internal consumption combustion engine, the gas boiler being driven from biomass plant, thermal storage equipment, waste heat recovery devices, uh, absorption heat pumps, cooling storage equipment, absorption chillers, heating, electrical energy, biomass, cooling, products. Can you imagine a power plant facilitating making of so many products? And I think I covered only one aspect of carbon capture, which is tile, but carbon capture is now also integrating with cement plants, where ready mix concrete is now having captured soot, so that the volume of cement goes down. So that effectively reduces the volume of cement that is consumed, and though at a per site level it might be a little less quantum, but on a larger level, imagine the amount of cement that India is producing. We are one of the largest producers of cement across the globe. We do so many cement, so high level of cement exports, that if carbon capture technologies are able to add to cement, then it is going to be a really win-win for everybody. So this was a whole presentation. I intentionally kept it around 1 hour. Also, I would like to cover a little bit about the energy modeling aspect, and Sir initially in the introduction mentioned we are in such a technology advanced world that whatever we are doing can be simulated. When we were studying, we had the fortune of talking about computational fluid dynamics and simulations of different kinds. But you will imagine that now architects who are designing buildings or who are designing factories or process, all of that is simulatable. Your air quality is simulated. There are software specifically designed to simulate microclimate. What is microclimate? Now, if you are sitting in a building, wherever you are attending this session from, what will be the temperature? There might be a generic temperature of 29, 30 degrees centigrade, but you might have a water body near to your place, and that might be reducing the local microclimatic temperature. You might have trees, you might have adjoining buildings. So all those things will reduce your local microclimatic temperature. And local microclimate plays a lot of role in energy consumption, in driving the growth down, and in ensuring that we don't become energy guzzlers. So all these tools are available, and in fact, a lot of this is now mandatory. So governments are mandated, for example, in the building sector, they are mandated the use of energy conservation and sustainable building code. Similarly, uh, I'm sorry. So similarly, a lot of different things have been mandated. Uh, what these things are doing is they are able to drive the growth of energy consumption down, and they're able to make sure that the products, when we talk about poly generation, if I go and tell a customer that see there needs to be a poly generation practice at your place, unless and until they drive profit out of it, they are not going to do it. So incentivizing, initially incentivizing through technology, there's a very famous company called EESL, Energy Efficiency Services Limited, that does work as an ESCO, which is an energy services company. So, for example, you want to try out a new technology and you are not sure of what the investment will pay you back. An energy services company can come to your place, replace your systems with a newer technology. You don't have to pay them anything. They will charge you out of the savings that you do. So, for example, initially your consumption was 100, it has fallen down to 20 to 80, and you have already saved about 20 with the use of poly generation or any new technology, or you are able to generate any output out of poly generation or any new technology, they will pilot it for you. They will do it free of cost. Out of the 20 rupees that you have saved, they will say that for let us say 5 years, and there are different economic models. For 5 years, we will give you 5 rupees benefit, 15 we will keep, 5 you have to keep. After 5 years, we will give you 10 rupees. After 10 years, we will give you 15 rupees. And after 15 years, you can take the entire 20 rupees of saving. So these are the newer models. Even financially speaking, they are very well available, and they are very upright in supporting, because ultimately the industry works on budget, the industry works on capex limitation. So if you tell them there's a new technology that can save you so much money, they might not immediately have the budget for it, and eventually by the time they implement, maybe 4 years down the line or 5 years down the line, a new technology may already be in place. So a faster way to implementation is just to work through energy service companies as well. And then there are a lot of good energy service companies now. In fact, the government's push is also to bring finance accessible in the energy poly generation, energy efficiency, newer technologies in energy efficiency. And finance committees have been created in every state, which comprises of state power department, which comprises of the state renewable energy department, which comprises of all the bankers at the most important part of it, because the bankers ultimately, if you go, you want to buy a land or you want to buy a house, you can call a banker who will do a valuation and who will tell you that this is the valuation of your land and this is the loan we can finance, and so you can go ahead and buy, and 15% you have to give a down payment. But if an industrialist has to buy an efficient pump, or if an industrialist has to buy an absorption chiller which will generate heating, cooling, everything, and will he get the finance? He will not get the finance, because there is no means to evaluate, uh, and estimation is not possible. So uh, that is being facilitated at the state level very actively by use of finance committee. There is a revolving fund that has been created at every state level, where private stakeholders can borrow money at a very nominal interest rate, and for government stakeholders, for government departments, for other government stakeholders, they can give a fixed repayment period of 3 years, and that fixed repayment period of 3 years will ensure that they get the funding, they don't struggle for the funding, and as soon as they get returns out of the savings on the investment that they have made, this is specifically for energy related systems, not for random borrowing. This is called a revolving fund that exists in every state, and these systems ensure that that the finance does not become a roadblock for any of these systems. So I think this was a lot in one single session around what is happening around energy policy generation, around what is really the industry moving towards. I am not from an academic background. We do a lot of work with the government around policy making and uh, industry. Uh, and thereby my expertise lies in where the industry is headed towards. And one constant challenge that we have always faced is the integration of the academia and the industry. And therefore this is one very important aspect that every industry needs to focus on. So this was the whole background around. I'm sorry, I'm just pouring water for myself. So just excuse me for a second. So so the whole idea of the presentation was to make sure and to give you an insight into what the industry is going towards. We always think that the government is maybe not doing enough, but the government is doing a lot on the policy side. And in fact, a lot of times the industry does complain that we are moving too fast, we are getting too many compliances. So there needs to be a balance because the evolution happens at a certain pace. But there is a very strong need that is to integrate the efforts that the academia makes towards research, and for that research to become mainstream and become adopted by the industry. So we have about 20-22 minutes. So if anyone has any question, I'm more than happy to take. And so this session will become more discussion oriented. Also, I will quickly write down my email ID here so that if anyone of you wants to reach out or has a question, can also reach out to me on the email ID. So I will just write down, and if there are any questions, please write it in the chat box, and we can take them one by one. And if any one of you has ever wants, is working on project that an industrial expertise can come handy in, we'll be more than happy to always work together. So this is my contact number and this is my email address. So please feel free to make a note, and I look forward to some questions so that we can make this session more interactive. So any questions from anyone?
Dear participants, so now you can ask the questions or any doubt you have.
I'll also share the email address and my phone number in the chat box so that those who missed it are able to take a note. And just so thank you Akashji for your question. Apart from power and cooling, heating, drying, uh, actual products like fly ash bricks are output out of thermal power generation, which is made of fly ash. We also have uh, chimney soot that is recovered to make products like tiles. Tiles is just one use that we know of. Who knows that the partition boards become one dedicated output. Fertilizers and chemicals. So a lot of waste uh, processing plants, such as the one I mentioned, the Hyderabad MSW plant, they generate refuse derived fuel. So power and actual fuel, and they are also generating manure because they get a lot of organic waste. So whatever they are able to see, they are able to also generate a lot of manure out of the power generation thing. So apart from power and cooling, I think we all know about it. It is very well evident that power and cooling is available. But apart from power and cooling, there are so many usable products, and I'm sure the limitation right now is about the number of things that can be made, but I am sure that as we start processing other kinds of waste, as we start generating power from a lot of other different uses, the outputs are only going to rise. Uh, Fly ash bricks is one very good example that have become a very commonplace utility in a lot of buildings now, and any other building that you see, every other building that you see has fly ash bricks being used. Uh, so yeah, power and cooling are definitely the base, but we have so many other products. I hope I was able to answer your question. Thank you, Ashok sir and uh, Tilok sir, for your feedback. Really happy to be a part of this gathering. Any other questions?
Sir, I have one doubt, sir.
Yes, sir, please.
How does thermal power generation contribute to energy efficiency and sustainability, sir?
See, in essence, it does not contribute to energy efficiency and sustainability, but we don't have a choice. About 70-80% of our energy dependence is still on thermal power plant. We still are very dependent on coal. So we don't have a choice but to make them sustainable. The question is, now Shell and companies like Reliance are saying carbon neutral. A lot of people ask that this is an oil company, how can it become carbon neutral? So oil is required. Similarly, thermal power plants are required. As of today, we are not so self-sufficient that we can survive without a thermal power plant. So this is out of question that Europe tried to shut down all its thermal power plants, and their prices went up, and they became uncompetitive, and now their economies are now struggling big time. You will read it a lot online that European economy, because of its over seriousness about sustainability, is becoming less economically competitive. It is a great thing to do for the planet, but as a developing country, we are also struggling for growth. So I think thermal power plant in itself is not sustainable. We all agree to that. But there are a lot of initiatives like 50-year-old plants are now, as per directions of Central Electricity Authority, are now being shut down in various states. So newer technologies are being implemented. Whatever refuse or whatever waste is generated is being utilized for different things. So per se they are not sustainable, but through PAT cycle, all thermal power plants are notified in PAT cycle. So the energy intensity has gone down, and their own self energy consumption has gone down. So these are strategies where you can try to make them more optimal and more efficient. But per se, as a fuel, obviously thermal is not sustainable. But we can do the
But
best
you
we
have
can.
said that, sir. But you have said that combined heat and power, combined cooling and power. You have said no, sir. How can it will be affected, sir, in main thermal power generation?
So power generation at the power plant level, maybe not, but there are a lot of captive power plants that a lot of industries use. So where they are able to use the waste heat for absorption cooling, and the waste first combine heat and on a topping and a bottoming cycle, followed by waste heat being used for absorption cooling, and whatever is the ash derived is being sent for different purposes. So on a bigger scale, if you talk about thermal power plant, they might not be able to use it for cooling, but the captive power plants are actually doing it. Even cement, fertilizers, all the large industries generally have a captive plant where they are also catering to process, and where cooling processes are also required. So waste heat is then used for cooling generation. Did I answer your question?
But it is important to combine heat and power also, no, sir?
Yes, sir. It is definitely important. Definitely important.
Thank you, sir.
Thank you so much. Thank you, Reddy sir. I now see that there are people from different parts of the country, and I could have been wrong in displaying Punjab as a case, but I thought any one state, we are all in the same country, so any one state should be able to present a good picture of where we are at, and more or less the energy distribution is very similar, where renewable energy forms a smaller percentage and coal and oil forms a larger percentage of the overall energy consumption. So,
So
yeah, any other
now,
questions?
sir, yeah.
Any
So
other questions?
anyone else? Okay, sir.
Thank you so much,
So
NIT
now,
Jalandhar,
yeah,
Rajan
I
sir,
would like to
Universal.
deliver vote of thanks. Just a minute, sir. So it is an absolute honor to extend my heartfelt gratitude to Engineer Kushagar Juneja for delivering such an insightful and thought-provoking lecture on energy modeling and building performance simulation for poly generation. His expertise and in-depth knowledge on the subject has provided us with a deeper understanding of how energy systems can optimize for sustainable and efficient building performance. So your detailed explanation on simulation techniques, energy modeling, and methodologies and real world applications have not only entitled us but also sparked meaningful discussion on the future of sustainable energy solutions. We truly appreciate the time and effort you have taken to share your valuable insight with us. Once again, thank you, Engineer Kushagar Juneja sir, for your inspiring lecture. We look forward to more such opportunities to learn from you in future. Thank you, sir.
Uh, Once again, thank you, Kushakar Juneja, for accepting our invitation and
So,
coming
sir,
and
thank you so
delivering a
much.
lecture.
Pleasure is all mine,
Almost,
and I hope I was able to add some value. And I
definitely,
look
yeah.
forward to keep interacting. And thank you so much for this invitation and your patient hearing.
Thank you for,
Thank you,
because you are
everyone.
Thank you, sir.
busy. I know you are busy in your busy
No,
schedule.
no,
You
no, sir.
came.
Always time. No problem.
Okay,
Thank
thank
you,
you.
everyone. Thanks for your presence.
Thank you.